Section 11.4 is on three-dimensional figures. The nice thing about us in STEM is we are constantly looking at three-dimensional figures, so this should be a lot of review for us, or at least something that we can at least concretely visualize very easily with our work in SolidWorks. Our central question is, what is the relationship between the numbers of vertices V, edges E, and faces F of a polyhedron? We're going to learn how to classify solids, describe cross-sections, and sketch and describe solids of revolution. To kind of get this started here, I just have a couple pictures up here. I have a two-dimensional square, a three-dimensional cube, and a fourth-dimensional tesseract. We gradually, throughout the course of your high school math career, have started adding an additional dimension. A lot of times you learn how to draw things two-dimensionally, and now you're starting to learn how to do things three-dimensionally. Eventually, you'll use linear algebra, and at the college level, start talking about things in the fourth dimension. Because we live in a three-dimensional world, it's really hard to perceive a fourth dimension. One such way that they are doing that illusion here is with time. It's the same thing with the cube. It's really hard to draw something that's three-dimensional on a two-dimensional piece of paper, but we have optical illusions to kind of take care of it. And that little bottom blurb says exactly what I said earlier. Today we're going to take a look at a lot of different three-dimensional shapes, such as a cube. And remember, we see these shapes all over the place, including in our design for the catapult we're working on right now. So to start this off, some of this is just going to be a little bit of vocabulary. If we're classifying solids, a three-dimensional figure, or solid, is bounded by flat or curved surfaces that enclose a single region of space. A polyhedron is a solid that is bounded by polygons called faces. An edge of a polyhedron is a line segment formed by the intersection of two faces. A vertex of a polyhedron is a point where three or more edges meet. And the plural of polyhedron is polyhedra or polyhedrons. Okay? The diagram to the right shows a really good example of what's going on here. That singular point right here on the edge is called a vertex. Any of those line segments are called edges. So when you're drawing these things, you're actually drawing the edges. And then a face is what the two-dimensional object would be. Here we have a rectangular face on this trapezoidal prism. Okay? So there's a picture of what some of our polyhedrons look like. We usually either have prisms or pyramids, and some examples of something that are not polyhedrons are cylinders, cones, spheres. To name these guys, we need to talk about the base and the shape of that base. To name a prism or pyramid, use the shape of the base. Two bases of a prism are congruent polygons in parallel planes. For example, the bases of a pentagonal prism are pentagons. The base of a pyramid is a polygon. For example, the base of a triangular pyramid is a triangle. So the easiest way of doing this is kind of just taking a look at some of these prisms, taking a look at some of these pyramids, and classifying them. It says tell whether each solid is a polyhedron or not. If it is, name it. In A, I definitely have a polyhedron. I can tell because I have a polygon as one of the bases. In this situation, not only is it a polyhedron, I can tell that this is a prism because I see two different faces that are parallel to each other, meaning I have two bases that's giving this shape. That shape that I see that's the same as a rectangle, which means I can tell that this is a rectangular prism. And I can tell it's a rectangular prism because I see two parallel rectangular bases and seeing how they're all connected. B, taking a look at B, again, I see a polygon in this, and I see that that polygon is being connected, so I know that this is a polyhedron. Again, there's the polygon. In this case, it's a hexagon. Again, I need to use the polygon that is its base to help label this thing. Because it is a hexagon, I know this is a hexagonal something. In this situation, I don't see two hexagons that are parallel to each other, so this is not a prism, this is a pyramid. This is a hexagonal pyramid. And C, I don't see a polygon anywhere in this thing. I see a base that looks like a circle, which means this is not a polyhedron. Not a polyhedron. Okay? I guess I should probably label this appropriately here. This middle one, we did say it was a polyhedron, just never wrote it. It is a polyhedron. Again, because it's polygon based. So what you're going to do now is you're going to try the same thing. I've got 3 more 3-dimensional shapes. I want you to pause the video and tell me if these shapes are polyhedrons or not, as well as if they are a polyhedron, tell me what the shape is called. Here we go. I got one was definitely polyhedron. I see the polygon there. It's a square. The base is a square, so that means that's what I'm using to identify this thing. And it's a pyramid because I don't have 2 parallel squares. I see it that polygon is coming to a point. 2 is not a polyhedron. Simple. There's no polygon anywhere in that thing. Okay. The only polygon that we have is this rectangle, but that rectangle doesn't really do us any good because it's not coming to a point, and I don't see another parallel rectangle with it. And 3, it is a polyhedron. Again, I can see that triangle right up in front. And because we have 2 parallel triangles, we know that this is a prism rather than a pyramid. And we have a triangular prism. And there is our introduction into 3-dimensional figures and how we can classify them.